So we have seen if we have an inductor and it is L, we know the reactance is j omega L. So if you have a current I, bar is used to show that it has angle also, it is vector. So I, then what will be the voltage? Voltage will be j omega L into I, that is voltage developed across this. This is V equal to j omega L into I, as if this was a resistor R, IR was voltage. Clear? Then if you look at it closely, you'll see I is equal to 1 by j omega L into V, or from here we can write I is equal to minus j by omega L into V. What is the meaning of minus j? You must understand, j turns a vector into plus 90 degree. That is, if you have a vector, let's say x, then if you say jx, if this is x, this is x. When you say jx, it means the magnitude will be same, and this has been turned by 90 degrees, jx. And when you say minus jx, this is jx. And when you say minus j, it means minus 90 degrees. That is this minus jx. Okay? Or to make it more clear to you, if we have a vector, let's say this is our vector A. Okay? It is at angle theta. Now you want to see what is JA. This means 90 degrees to this. That is this. This will be your JA. This angle will be 90 degree. That is, from here to here it is 90 plus theta. Similarly, if you want to see what is minus JA, this is minus J. This is minus 90 degree. So this is minus JA. Okay? Clear? So what you get from here? When you say I is minus J some quantity into V, that is, if we have V as this vector, we are talking of vectors only. If this is V, minus means it will be like this, I will be like this, turned 90 degrees negative to V. This is, the expression is called I lags the voltage by 90 degree. That is, I am writing this, keep this in mind. In inductor, I am using L for inductor. In L, current lags voltage by 90 degree. This is very important. Later on you will realize what it means, because our circuit is having sinusoidal excitation. So we will have to understand these things. So this is about inductor. Clear? Phasor of inductor. If this is V, I will lag by 90 degree. Clear? Now let's see about capacitor. Resistor, you know, if you have a resistor R, so if this is V and this is I, V is equal to IR. That is, if this is V, I is also here. I and V are in the same plane. They don't have any phase gap. This is when it passes through resistor. This you must be knowing from the very start. I told you about inductor. Now let's see about capacitor. This is C. Let's say this is V and this is your current I. You know very well what is this. V is equal to 1 by j omega C into I. This is the capacitance, XC, reactance is 1 by j omega C, or J, if you take it in the numerator, this will be minus J by omega C I. Now this is just reverse of what we saw in the inductor. Here what you have, if you have current, voltage will lag by 90 degree. That is, if this is I, your V will be like this. Okay. So in capacitors, V lags I by 90 degree. Okay, remember this. So we have a term called civil to remember. Sometimes what happens when you are solving problem in examination, you will just forget voltage leads or lags. Remember this term civil, it talks of leads only. So we say like this: in capacitors, current leads voltage. See, in capacitor, current leads voltage by 90 degree, and this is inductor. So voltage leads voltage leads current in inductors. In capacitor, current leads voltage and voltage leads currents in inductor. Just so that you remember this. And how do we write KVL and KCL? For example, if this is our circuit, this is R, this is L, this is C. So we have a frequency representation. Let's say the applied voltage in phasor form is V. Okay, this is R, and this is L, and this is C. This is I. Let's say this is I. So how do we write? We write R into I plus j omega L into I plus 1 by j omega C into I is equal to V. Clear? Frequency representation. Ri j omega L 1 by j omega C V. Now we are trying to solve steady state analysis problems. Clear? And if you want to see what is the impedance that I am rubbing this. If you look from this point, what is the impedance or across this terminal? So let's say the impedance is Z. So it is R plus j omega L plus 1 by j omega C. This is when multiplied by I, that is Zi is equal to V. This is what we did here. Okay, and let's break it further. This is R plus, take j out here. Here what you will get? Minus. J in the numerator will be minus. Why? Because j square is minus 1. So this, if you take to the numerator, it will be minus. So this is omega L by minus omega C. So this is the impedance. We usually what we do? We write it like this: Jx, where x is what? X is XL plus XC. This. Okay. And if you want to see what is the modulus, that is Z, it is R square plus X square, that is this square under root. And what is theta? Theta will be tan inverse this by this. This is basically a complex number, and you must have studied complex number. So all the algebra of complex number is applied here. So we can write this Z as, in this angular form, we can write it like this: Z angle theta. Okay, this is useful when we have V as, if I apply 10 angle 50 degree. So what is the current? Then if you find Z in this form, current will be very easy. V is IR, so I will be your V by Z. So if this V is, let's say, 10 angle 50 degree and Z comes to 2 angle 30 degree. Let's say if you calculate, it comes to this. So very easily you can write the current is 5 and this is the angle, this minus this. So this is 50 minus 30, 20 degree. This is pure complex number mathematics. Okay. So from here, let's see, sometimes in the start you have to find impedances. What is the equivalent impedance of a circuit? Let's say my circuit is this. This is R, this is this, and this is this. Very simple RLC circuit. We want to find what is Z. This is 5 ohms. This is 5 Henry. This is 5 farads. Okay. So Z will be R, that is 5, plus J into omega L. So what we need to know? We need to know what is the angular frequency here. Let's say angular frequency is 10 radians per second. So this is omega L, that is 10 into L, 5, minus 1 by omega C, 1 J we have taken out. So this is 10 into 5. Okay. So this is 5 plus J50 minus 1 by 50. So whatever it comes, this is very small quantity, so you can write 5 plus J50. This is the equivalent impedance. Okay, so if this was, let's say, 0.05, then this would have been 0.5, that is, this was 2, so it was 48. So this would have been 48. Okay, generally capacitors in the market, the capacitors you will find they will be in microfarads. The capacitance is low. You don't have 5 farad, 10 farads type of capacitors. You will find capacitors 50 microfarad, 10 nanofarads, and so on. Okay, so this is how we find impedances. And impedance when in series and when in parallel, we have impedance in series. It is like Z equivalent is Z1 plus Z2 plus and so on, as we do in the case of resistors. And impedances in parallel, it is same as we do in the case of resistors, that is 1 by Z equivalent will be equal to 1 by Z1 plus 1 by Z2 plus and so on. Clear? And the reverse of impedance is called admittance. That is, it is denoted by Y. So this is 1 by Z. This term is called admittance. Okay. Now let's see first question. This is, I am explaining these questions, I am solving these questions so that you get a start how to solve problems. A current of 15 amperes has been applied to this parallel network. We have to find what is I1, that is current through this impedance, and I2. Now 15 amperes means 15 angle 0 degree. Okay, when you are given only 15 amperes, this means the angle is 0 degree. So how do we get? I1 will be, if you remember parallel circuits, if you want to find what is this current, you say this impedance in case of resistance, this resistance by this plus this resistance into the total. So this will be 15 angle 0 degree. This is the total current. So I1 will be 6 minus into 6 minus J8 by these two, addition of these two, that is 6 minus J8 plus 10 plus J15. Okay, so this is I1. The only thing we need to do is to solve this. How do we solve this? See, 6 minus J8, I told you, let me explain this slowly. This can be written as root over 6 square, that is 36, plus 8 square, that is 64. This will be the modulus, and angle will be tan inverse minus 8 by 6. Okay, so this is what? 36 plus 64, 100, that is 10. Okay, and 8 by 6 is 1.33. So if you take tan inverse of this, it comes to 53.13, but this is minus. So this becomes minus 53.13 degrees. So we can write 6 minus J8, this is in rectangular form, we can write it in phasor form, polar form, like this. Similarly, this is what? You will get 6 plus 10, that is 16, and this is 15 minus this 8. So this will be J7. So what is 16 plus J7? 6 plus 10, 16, 15 minus 8, 7. So 16 plus J7. So this will be 16 into 16, 256, plus 7 square, 49. And angle will be tan inverse 7 by 16. So let's find, first of all, let's find what is the angle. 7 by 16. And you take tan inverse of it. So it is 23.63. The angle is 23.63 degrees positive, and this is when we are taking this, It is 256 plus 49, that is 305, and we have to take a root of 305, that comes to 17.46. So this is 17.46 angle this much. Why we have to do this? Because we can multiply or divide only when we have in polar form. So instead of this, I am writing now this thing. 6 minus j8 is 10 angle minus 53.13 degree by 16 plus j7, that is 17.46 angle 23.63 degrees. So what do you get? 15 into 10, 150. See, 150 divided by 17.46. So this is almost 8.6. The value is 8.6. And angle, what we do? This plus this minus this. Whatever is in denominator, that will be minus. So 0 plus minus this minus this. So minus 53.3, 53.13 with minus 23.63. So you get 76 minus 76.76. So this is current I1, that is in this circuit. Okay, I am keeping this value because for I2 also we will need this thing, this plus this. Okay, this is in polar coordinate. What if you have to if you want to have it in rectangular form? So you know this is equal to, this is ej theta, that is cos theta plus j sin theta. So you will take 76.76 cos of this. See, cos of 76.76, cos of 76.76, that is 0.229 into 8.6, 8.6, that is 1.97, and then we will have minus because cos theta plus j sin theta. So the sin theta becomes minus. So 76.76, we have to take sine of 76.76, that is this quantity, into 8.6, 8.6, that is 8.37. So in this form, a plus jb form, this or this. So this is your I1. Okay, now let's see what is I2. For I2, this is same, only I2, this is I into, this is addition of both. Only difference will be, we'll put 10 plus j5 15 here. Okay, so now I am rubbing this. So let's see what is 10 plus j15. We can write 10 plus j15 in polar form as under root 10, that is 100, plus 15, that is 225, and your angle will be tan inverse 15 by 10, that is 1.5. Let's see the value. 1.5 tan inverse. And this is 100 plus 225, 325. So root over 325 is 18.03. So this is this. I am writing in place of this, I am writing in polar form 18.03 angle 56.31 degrees. So let's find this value. 15 into 18.03 divided by 17.46. So we get 15 point, it is almost 5, and angle will be 0 plus 56.31 minus this. So we have 56.31 minus 23.63. So we get 32.68. And if you want to see it in rectangular form, this will be 15.5 into cos of 32.68 plus j sine of 32.68. You can multiply it. I have told you how. Okay. Let's see another example. This is RLC circuit. V is given as 100 plus j 200. I, this current is 5 angle 0 degrees ampere. Omega, the angular frequency of the input signal is 1.2 kilo radians per second. We have to find what is C. Very easy. It may look, how can we find, but it is very easy. See, I told you this is the impedance is what? It is R plus j omega L minus j by omega C. Okay. J is in the numerator. This into I, impedance into I is actually V. Clear? So R is 20 ohms. J omega L, J into omega, omega is 1200 into L, L is 0.05. Okay, and we have J by omega C, that is 1200 into C. We don't know what C is, we have to find C. And V by I, what is V? V is 100 plus J 200 by 5 angle 0 degree. See, this is angle 0 degree. We can either you can convert it and then divide, or individually this is algebra, so this will be 100 by 5 angle 0 degree and then this by this. So because this is 0, it won't affect, so this will be 20 100 by 5 plus j, see 200, so it is 40. So this side we have this value. You can, if you have any confusion, you convert it to polar form and then you divide it, you will get this only. Okay, so if you have this thing, you can directly divide also. Just look at this side. This side is 20 plus what is j 1200 into 0.5. See, 0 means 5. So, and 5 into 12, 60. So, this is j 60 and this is j by 1200 C. Okay. Now, 20 cancel. See, this is 60. So, this side when it will go, it will be minus. I am doing it. So, if you take J60 to this side, it will be minus J60. So what you will get? Finally, you will get minus J20. So this cancel. From here, what you get? C is equal to 1 by 20 into 1200 farads. So what is this quantity? I am writing it here. So what is this quantity? C is your, let's say we take microfarads. So we'll have 6 zeros. I could have done it right here only, but to explain you, I am doing it slowly. 1, 2, 3, 4, 5, 6. So this is now microfarad by 20 into 1200. So 3 zeros gone. So this is 1000 by 24. 1000 by 24. So what we get is 41.67 microfarads. So we have found the value of C. So this is how we do KCL and KVL in a circuit when subjected to a sinusoidal excitation. Okay, this is steady state analysis. You should try some questions, and this is very easy. It's not very tough. Try, you'll understand it.